Welcome everyone for Cloud Computing and Big Data. Today we have our short lecture 7 on large language models, also known as LLMs, and also generative AI in clouds. So this is definitely a relatively new lecture now in the series, mostly because you have observed the relevance of large language models, I think, through ChatGPT and many others, Mistral, etc., over the last 5 years. And we see now more and more that the workload in clouds and also in HPC are really increasingly large language models, but also foundation models. And we will talk about this today. Also leveraging then this generative power that we will discuss today to generate really content in AI, which is sort of new. We don't want to generalize only what we basically do in AI, machine learning and deep learning before and a long time. Now we're talking about really generating text, generating images, generating sound, generating videos, you name it. But before we talk about this, let us review a little bit what we had in short lecture 6. And this will also be one interesting connection to the lecture today. So we did the move in the deep learning applications lecture of saying, yeah, we had this interesting idea of a multi-output perceptron. You see that here, of doing then this, handwritten character recognition. By now, you should know that by heart, I guess. And we know we had around 90% performance, and the really learnable parameters, which is also something we will rediscuss today, is what you see here. The W's, sum them up linearly using weights here, and then put it through an activation function and so on. The idea of one neuron, in a way, if you want, will be coming back to the neural networks, is coming back to the deep learning networks. And interestingly enough, when we talk today about transformers, is basically nothing else and also a neural network. So in the end, the computing complexity, however, is for us the one, which is in this particular course very important. So we left out several details from deep learning the last time. Firstly, because you should basically visit a real machine learning course if you're seriously interested in this topic. Secondly, we have seen a very good introduction on the basics from Andreas Lintermann. So, but what we learned is the more powerful really the neural network is. And you see that already here when we talked about the two hidden layers, artificial neural networks trained with back propagation of error through the layers using the chain rule. There was already an increase in the parameters to learn, right? Much more weights, much more connections, 120,000 roughly. And you can carry on. And then we said, okay, we have this convolutional neural network, which is quite very interesting. It preserves the 2D input, for instance. It carves out features, pooling them for the convolutional operation, strengthening this with new feature maps. So in one respect, we talk about feature learning, while the last part is then really flattening and the dense layer and the output layer here with a softmax activation function still to make then the actual classification, right, of the digits we have seen. So a bit a different system, and this will allude also to the idea of deep learning that we will discuss today in large language models. I'd said you before, deep learning doesn't mean you put just more hidden layers and hidden layers like you see here with the artificial neural network here. The interesting thing is that really deep learning has evolved with cutting edge performance, doing very specific things for very specific problems. And today we will talk about, encoding, decoding, attention mechanisms, transformer models. Also this only to a limited degree because Andreas has already introduced this thoroughly. And it would also fill 2 university lectures, basically, if you want to introduce our transformers very well. It's quite an interesting topic. But you go there and you see the parameters will rise. And what for us was last time really 1.2 million, quite a lot. We will laugh about that today in our lecture. So, but however, you will see the computing footprint for those that also want to try out these scripts we have uploaded into Canvas. You see basically for the performance that you get, better performance with deep learning, 99.3% of this toy problem with handwritten characters recognition, then of course you have to pay the price for it in computing. So we looked a little bit what computing, is offered in the cloud, and we saw very quickly the limitations of Google Collaboratory. Also, when you think about real production data from marine data we have seen in the SME Greenfish example, right? Loading up gigabytes and so on and terabytes and so on is not really feasible. So you have to move to one of the cloud providers. And we had the examples of Amazon on different cloud levels. And this is not the only service you could pick. There's, definitively the HD Insight. There's different MS Azure offerings where you can go to and have similar aspects that we saw, connecting it nicely to virtualization on the infrastructure as a service level. So you have sort of, virtualization to the rescue and have some prepared images that are called the Amazon Machine Images here, which are already fueled with deep learning packages, which is very much on the lowest level, if you want, in the clouds, right? You still have to log in with SSH. Here and there, we have seen there's some Jupyter Notebook, however, much better. So then we already talked about Amazon SageMaker idea, right? So that you have a fully fledged managed service, as we call that, with nice tools we have seen. But this is really already on the software as a service cloud. And needless to say, also SageMaker and this higher level services, we will also basically now learn in the next couple of weeks that are left in the course. They, of course, making use again on the infrastructure as a service on the lowest level. So it's different abstraction levels we will discuss. However, let us come back today to a very interesting lecture. You see, it's new, given the rise of large language models and the relevance in computing. So we'll talk a little bit today, what is LLMs, but as I said also earlier, alone the topic LLMs for this short lecture is really challenging. Basically, we could say that large language models and generative AI could be a complete course, right? You heard correctly. I think there's so much fundamental materials for generative AI, leaving also maybe the space of languages, right? We will discuss this a little bit very briefly today, that of course you can use generative AI also for satellite images, for instance, in the remote sensing group in the HPC community in Iceland. So huge topics. However, we focus here in this course on the compute and storage needs again and again, which brings us quickly to the idea of this, billion parameters you have heard probably, right? So we will talk about this. We see how that materializes over the last couple of years. And then we will here and there have good examples and also limits of the large language models. Something you may be already hopefully aware of is hallucination, but there are also other interesting challenges we will discuss, and also opportunities, because we will also understand more and more that basically these large language models that we have are sort of foundational models, as we call it, for downstream tasks, for task fine-tuning, where you have another application and another application and another application, etc., etc. And you reuse the foundation model again and again. You just tune it for the specific task at hand. With this, you save computational, footprints. You have once this foundation model maybe trained with lots of cycles, lots of power, as we will also observe later. But then for the task fine-tuning, usually it doesn't require so extreme much computing again as starting from scratch, for instance. So this is an interesting also, if you want, green computing aspects we will briefly discuss. And then obviously we will go through all the cloud vendors, MS Azure, AWS, Google Clouds, what they have to offer in the LLM space, in the generative AI space, and we'll have some application examples. At the end, I would also give you a little bit an insight what we do in science, what's happening in research, and also when you think about open source models, we quickly talk about sovereignty of clouds today, using large language models for countries, for governmental, for the public sector. And I will also make some interesting cases why actions on regulations are really happening and necessary, as we observe in the European Commission space at least. So again, here the disclaimer, of course, some of the material like transformers builds really on the material of Andreas. So there's no point of reintroducing this today, but of course, this is a fundamental topic you should understand a little bit with encoding, decoding, or this interesting attention mechanisms, which really for natural language processing is here also a very important part today. So hence, however, normally this topic, LLMs and generative AI, would be a complete course these days. So let's dive into it. And I think the impact of deep learning I would like to connect to is I think pretty clear by now. And this was the increase of parameters, as we have seen, the very specific architectures that we have seen with convolutional neural network in vision, for instance, but also natural speech. We have seen more and more advances, and I come to one concrete model called the long short-term memory, which is also one deep learning model which stood the test of time, but was happening, let's say, time before the transformer models really came, but had really breakthroughs, for instance, also here in liquid flow, which is an LSTM model generalizing well to physical problems, which is quite, let's say, remarkable, because usually this was more the fluid gas dynamic space of the physical modeling, not of the AI learning from data. But with these powerful models, lots of impact could have been performed. It was performed, as you see here, as an overview. And you can look in the Center of Excellence race, a new project we had, where, for instance, talked about transformer models with some other colleagues and many other elements that may be interesting for you, like autoencoders, rate tune, hyperparameter. We come back to this a little bit, graph neural networks. So, and all of them share, of course, now the interesting aspect that they need a lot of data and a lot of compute. Right, but we have seen with this, we have really done lots of breakthroughs, but transformer models now stand a little bit out, which we will reveal today. We should not forget also that basically several of these ideas of deep learning have been around since maybe at least the 70s, when neural networks were on vogue. But the trouble was there was not really computing power available. So the success that we see in deep learning, and also especially now today with large language models, is because we have access to very powerful many core architectures. I mean, many of you know we use the Tesla series from NVIDIA a lot, and tensor cores these days, and the key idea is really that we, as you see here, we can, as many of these deep learning, layers do nothing else in the convolution operation, for instance, and in others, matrix multiplications, maybe here and there matrix vector multiplications. And we see that here in the color coding, very beautiful, how this can be nicely parallelized, right? So in order to compute the result, maybe you see that a little bit here, we don't need the whole picture. We just can basically, as you maybe remember a bit from math, use this color coding here to compute this on different processes, which could be within nicely this, many core architecture here in a GPU, having access to the device memory where this matrix is stored, and then independently compute from each other the results that you see essentially here and coming and computing the overall picture. And this was by far now one of the computing breakthroughs that also make deep learning then so much advanced, and also made the way also to these transformers that we saw today. Now, initial successes, however, coming slowly also to the idea of large language models, but something where, the community with NLP, natural language processing, was long times thinking about sentences of sequence models, as we said. And sequence modeling was mostly recurrent neural networks, which will be unrolled. You see here, basically giving the different inputs in over time. Or, as you can imagine, a text, or let's say words, are nothing else than a sequence of characters, right? You see here the hello, right? That was basically put into, this kind of unrolled idea. And then you basically compute the weights. You still have weights here that you compute, right? It's a bit not visible here. And then you could predict what's coming next. After the H comes an E, after the E comes probably an L. So we have the probabilities here with one hot character encoding, and so on and so on. And initial models were recurrent neural networks. Then the long short-term memory came with some interesting concept of having, borrowed the idea of computer science, having here a storage of memory. So in the end, talking about we could, remember longer aspects in sentences, in sequences. And this was another sort of, if you want, breakthrough, because these models have been quite robust also because of this memory, and also have shown in many of our applications very good performance. You see here Landsvirkjun, for instance, good predictions of power lines, but also these days you can see them in many other elements, in medical signals, speech, and so on. So in one respect, people have started then stacking these LSTMs, and this was really another breakthrough for translation, really, that you saw also in cloud computing. Lots of services were based on LSTMs, sometimes also on gated recurrent units. They have a bit, let's say, having less gates here is not so elaborate like the LSTM cell that you see here, but still had very good performance. So these were all interesting parameters, and here's an example of natural language processing, how that was working. Here you see also the amount of data, again, suggests more or less a toy problem, to be honest. But it captures the essence that these models of sequences were also working very well with text, at least to a certain degree, right? And we see here sentiment analysis. So we want to understand if, someone would judge us similar like our, restaurant experience in the course. Now we're going to talk about movies here from this, let's say, Kaggle data set that you have here, sentiment classification, just saying that my statement about the movie was positive or negative, right? Again, a binary problem here. So not really, let's say, a large problem if you want. But this is something where LSTMs could work very well, which I show you here quite nicely when you train it and have worked with it a bit. You have to massage the input, obviously, so that you have sequences again going in as it is unrolled here, right? To predict then what would be probably coming as next, and would give you also then quite nicely, let's say, the idea of is it a positive or a negative, basically statement I did. And of course, it was a supervised learning problem. So in this sense, you remember from earlier parts of the course, even that is much more simpler than having unsupervised learning aspects that we will discover a bit with large language models today, because we call them semi-supervised sometimes, and I will make a case for it. However, you can see that with 97% performance, this was already very good. But what happens if you now have, let's say, more and more text? What happens if you want to improve, on a larger problem, like, for instance, generating text? And this brings us to this interesting new field where you say generative AI, large language models. You remember this slide. This is really the field of what we had here on the top in the beginning of the course, right? So here we're talking about a huge training time footprint. We talk, of course, beautiful accuracy enabled through this interesting concept called, self-attention mechanism. And you see that a little bit here with the encoder and decoder structure that you have seen also in Andy, slides. And if you want, this was a really breakthrough of this from a famous Google paper in 2017, bringing then a complete new idea of modeling here in. Although, I mean, basically, if you see a little bit, it's still, of course, sequences the text, but now we can look at the text much more broader, bigger. Of course, we have to pay the price for it. Much more data is needed to fill transformer. Much more computing is needed to compute billions of parameters, right? When we talked about, we had here 120,000, we had 1.2 million in medium deep learning networks on convolutional networks. Now we are in the billions, right? And this is something where high performance computing, cloud computing is really needed. So let's talk about LLMs briefly. And I'm sure if I would stand in class today, I would ask you about OpenAI and ChatGPT and, who is basically using it and who is not using it. I'm very sure many of you would raise their hands. And those that don't raise their hands have at least considered it, trying it sometimes. So this is really, of course, today something which is very known. And you see what's happening. I can actually use it like Google, right? If you remember, Google was sometimes, the search engine that people search something in, then it became more YouTubing material, right? Then people have started to use YouTube more, like, trying to understand something. Now we would almost say we chat GPT it, right? In order to find out what a language model is, for instance. And that is the interesting part in it. It's a very powerful tool. Natural language processing seems to be the main driver, obviously, because many from us are just humans and are interested in that. And there are many use cases that you see nicely here from the NVIDIA idea of using this encoders and decoders with the transformer models for many downstream tasks and use cases, right? We will explain why we call it downstream, but you see this kind of transformer model could be mostly interesting for us today, content generation. Very new, right? Creating new sentences. I mean, this is something where these models are now striving and also go to different modalities, as we say, so covering not only text, images, sound, video, etc. It can summarize documents very well. It can translate. I mean, Google Translate, doesn't work for everything, like small countries or low resource languages. We will talk about that later. And classification, chatbots. You have seen almost all big vendors today, or basically professional websites, have a chatbot talking to you. Do you need some help? So I think this is pretty obvious. And what is really fueling is this transformer model that we have already learned in Andreas' slide. So, and I was already talking about it. So basically, that is something we also know. And for us, it's important how we phrase these prompts, right? So what we see here, prompt engineering is also something we will come later to when we want to maybe retrain and fine tune a model. But let us briefly discuss the role of trainable parameters. I already basically said to you, we talk about billions of parameters, and you see here quite nice overview from something which is in the web. Really, information is beautiful. I would recommend you this website. But the interesting thing here is GPT-5, GPT-4, things from OpenAI, but also Mistral is one basically based on European values. We will talk about this briefly also. But here we talk about really parameters of billions with a footprint, right? GPT-5 is a bit smaller, but your GPT-4 Classic here in the past was quite big. So you see more and more that these kind of, either they are very specifically trained for specific problems, or basically they also need a lot of computing time. And you see that a little bit why that is. And here's a little bit the stages you have. So 1 to 3 billion, you would say, is simple natural language processing, where you would have a shallow context understanding. So these models are not very powerful, but might be enough. So here we talk also about a trade-off of using computing, right? And then when you think about 7 to 13 million, this is a normal chatbot, maybe you can use it already for some summarization. And then you have a moderate compute cost, which is maybe something which many people would be already happy with, right? So the point to go to 30, 70 billion is really you have a very powerful machine, code generation, multilingual translations. This is something where you really need lots of GPUs. And what I see also at the end of the course, I will show you a little bit when we go to multimodal research, right? We have satellite images, radar images, different types of modalities. And then you really need extreme computing costs. But of course, it's also really rewarding for the community. And this should be just now a feedback what we had already. And when I, talk about the last course hours, I mean, here we ended up with 1.2 million. Now these models here, LLMs and generative AI at large, is in the billions and more, right? So this is a growing field. Question is, however, if you increase more and more these billions of parameters and so on, is it really better, right? Or is not data being the bottleneck? For some of the languages, it surely is, right? Take Icelandic, right? We cannot have more and more text corpora. So having a billion, hundreds of billions parameter space to learn will not work because we cannot feed it with, let's say, clean data sets. We don't have just enough text corpora in a low resource language. And just to make a kind of link to the cloud course when we talk about costs, right? So when you want to have something very old trained, a GPT-3 model with 175 billion parameters, then this could stew around basically $12 million in just computing, right? I mean, in science, we are lucky we have these machines for free. But if you're an enterprise, then it's quite extremely costly to do this. And hence, you can imagine GPT-4, GPT-5 for OpenAI costs quite some money if you translate it, one-to-one. Again, also the good news is that the vendors don't stop, somewhere. So we see here a quite interesting movement the last, let's say, 5 years with A100s being cutting edge from NVIDIA. And suddenly the Grace Hopper or Hopper architecture come along. And today we have even H200s, right? But you see, even within, let's say, the same hardware, NVIDIA doesn't stop. And I'm not paid by NVIDIA, just for the online audience, right? So just saying that they also don't stop to really tune and actually work also on the software, on the drivers, on everything which you would say is not directly the hardware, but would make it work faster and faster that you see here with the same hardware 1 year later, you have even more speed up available. So that shows you a little bit, and also here you see the kind of Megatrons, BERT, all this basically language models you know a little bit if you're in this field. For you here in the course, it's important in the moment to say, okay, not everyone can train these models. It's much more better that someone has trained it, put it there, and I can maybe refine it, retune it for a specific problem at hand. And this brings us to the idea how essentially the LLM development work as a stepwise overview here. And I want to make the connection a bit to the CRISP-DM that you already learned as a kind of modus operandi machine learning, because we change a little bit here the game of saying, we have, let's say, typical data sets where we pre-train a model, right? Pre-train means it's basically trained on lots of basics and lots of modalities, perhaps, let's say on text, tokenized text, ready for English, ready for French, whatever. But then essentially what we want to do is we want to have an alignment step which adopts then the basically the LM for very specific, as we call it, downstream tasks. And this requires usually, and this is an interesting aspect here, right? You see this recycling. So we have this pre-trained model staying there, being ready, being shared, and then we use it with some alignment data set, maybe refine it, fine-tune it for some specific problem at hand, right? Let's say you have a language model which is English generally, and then you would have text data a lot, texts, up, down, documents, you feed it with text documents, and then you can basically have a chatbot for the tax authorities online, maybe giving many people, let's say, already basic answers to tax law and tax, challenges they face. As many of you know, tax and so on is usually a very time-consuming manner. But this might be one example where public organizations also can really benefit. So it's not only industry, but also the public sector more and more is requiring this foundation models, this pre-trained models. So hence we change the picture a bit of the idea from, you would say, the CRISP-DM. And just that you know, this RLHF, reinforcement learning from human feedback, stands for the fact that in this process that we did here a little bit automatically with modeling, we have now some reinforcement learning in this process here, right, with human feedback, if you want to fine tune it sometimes. That really depends on the task. There are different ways how to do it. You can also basically have prompt engineering, where you have very specific inputs again and again, again, text law, whatever you do in terms of a chatbot, you fine tune it for the text at hand, and then, could be a very relevant, suddenly language model that you deploy. Of course, you have to evaluate it with different mechanisms. And then you have really in the deployment, in the text office, a conversation going on, with the people maybe that want to, talk to you as a tax office, or you have it in Statistics Iceland, let's say a statistical organization that can do lots of, quantization of statistics, can talk with you about the latest, greatest of fishery, what's coming out and what was reported without a real human being in the back. So hence, again, the point is here really this pre-training, using this sort of foundation model for the language potentially, and then, reusing this, it's basically here, and saving in this sense, that's why I marked it a bit green also, here you save computational compute time to train these models. If you want to put this in our practical machine learning overview, we also change the picture a little bit, just that firstly, you would say transformer models, which we would have in our hypothesis set here with lots of billions parameters, do nothing else in the learning algorithm in a way like variations of backpropagations and gradient descent approaches you have seen probably also with Andy. So the learning algorithm stays a bit similar, but we don't have necessarily always supervised input, right? Let's say Icelandic text corpora would be something we want to maybe feed in, but we still want to maybe do some reinforcement learning from human feedback. So basically change some of these aspects, want to do prompt engineering. And with this also, we basically have a different idea what the error measure would be. However, the general modus operandi stays. It's just basically that we rather have a mix of unsupervised learning, maybe in the beginning with not really labeled data, and then you switch a bit to supervised approaches. In a way, you would say it's more a semi-supervised approach using this attention mechanism that is, inherent in the transformer model, for instance, and then, changing the game a little bit by having also new aspect that human in basically in this process have some insights, right? So, and this is important, of course, you can imagine, because human standards are usually quite good. If you have a poor Icelander, for instance, that can talk Icelandic, this probably can really quickly identify if Google Translate works or not. And usually we see that here and there it's many flaws. Now, we come to some challenges. I think many of you have already heard this hallucinations or references are created on the fly, which don't really existing. One famous picture is here, this one from Santorini. I think that's an image example of generative AI where it really looks good. And if you have been in Santorini, it's really a nice place. I have been there, I love it. But this pool is not existing and not anytime soon. But it looks on the first glance really fantastic, right? I mean, this is, if you know, it's very hot there and having water everywhere and perfect. But if you zoom in, you see, the photo that seems to be someone did on his vacation has really interesting humans, right? So some losing the hands, here's a half of a body, or the hands have very interesting, artifacts, as we call it. And the same is true if you look on some image generated faces, you see sometimes extremely many teeth, right? So this is something which is not existing, this person, but it looks pretty real. And here are some other, let's say types of hallucination, context hallucination, where basically the kind of the model respond completely to something, from yoga going to astral projection to something completely out of context. Then semantic hallucination, where basically that the whole process really didn't is magical. It's really, I mean, basically a real mechanism that is important and not enchanted, right? Like magic or something. So it lacks a little bit, the real depth, fuel, mechanical processes, combustion. All this is basically saying, oh, well, there's some magic inside with unicorns happening, making this car work. And you can go on, you see content, factual hallucination, or a very good one is here also for lunch. You suddenly change here, see different hallucinations in a way where you go from lunch suddenly and get something for dinner, right? Recipe for dinner. That's not what I'm asked for. And basically lunch and dinner is here a problem then, but also out of nothing comes the steak, while basically something, a chicken with mashed potatoes is provided. So you see there are interesting aspects in it, which means we should really be careful using these. However, we see, and I also want to make positive notes now, of course, here, that MS Asia is using this a lot in this cloud offerings. We will walk through a couple of them a bit faster because, I mean, this is sort of just showing you also what's on the websites more or less. But you see here that ChatGPT is adopted by Mercedes-Benz really in productions using the Microsoft Azure cloud. So hence, the cloud vendors bringing us now back to the cloud computing, course, really offer all these popular models inside the cloud today, right? And the reason is that you also need a lot of storage. The reason is even for fine tuning, you need some computing. So you choose several models. Here's an example of the MS Azure cloud with the AI Foundry models, where you find again those that we have seen before with GPT-5, basically from OpenAI, but also Mistral based on European values and so on and so on. So you choose these models and can create something out of it. You see a Google Cloud Service here as an example, which has a Vertex AI Studio. And if you, using this and the Gemini, model in the back, you feel again like ChatGPT within the cloud. So it's basically similar. Hence, you can also create your own applications based on this and combine it, which is already in the Google Cloud, making it quite interesting to maybe move now here very quickly through some document summarization, because some of the aspect like BigQuery is not obvious to you, but we will talk about this, the cloud storage very soon. but you connect it nicely with AI services now for vision, for this Vertex AI large language model ideas, and then basically have a whole cloud offering ready, to be shipped to your customers. And of course, everything these days is also steered with a large language model, helping you even what problem you're trying to solve. So hence, you can go on and go on, and we will make some examples also later in the course when we talk about platform as a service, where we come back to these building blocks of large language models, right? Which are now, are pretty clear, I think, right? You can see that some of these large language models are just provided as a platform, and then you can use it as individual tools for what you want to do. Do you want to do an agent assistant, right? Or a chatbot? What's the point, what you want to use it for? Is of course depending now on your application when you use a cloud for customers you want to do. And Google gives you then, of course, also the infrastructure like Amazon, like, basically also MS Azure. So let us look a little bit when we now look in this generative AI space. This is a bit broader. We have this, basically idea again here, generative AI assistant from Amazon. Of course, you have this closed source cloud service portfolio. But generative AI is now basically a little bit larger than just thinking this large language models, right? Here now we're thinking really in embedding these aspects in different sectors in business for very different purposes. So you see here some of the movements like GenAI for EU from the European Commission, where lots of money is actually activated to have it as a flagship initiative, not only influence public sector with generative AI, but as we have seen, mobility, car engineering with Mercedes-Benz, and many other aspects. So one example is that the OpenEuro LLM, so it should be an open source foundation model within Europe, which should be available for people to reuse without paying aspects for OpenAI to use ChatGPT or so on, or Mistral, etc. So there's a movement. Of course, the, let's say, evaluation of these models may not be as perfect as the cutting edge ones of OpenAI, GPT, which are quite good. But still, it's free. And with this, it gives us also possibilities to tune them ourselves, to work with that ourselves, and so on. Another example of a cloud service, which also now brings us a little bit to revealing the cost behind it, right? By now, I always review that a little bit. In Amazon, you have something called Bedrock, which is then the LLM idea, very similar like we have seen before in the Google Cloud with the services, very similar like we have seen in MS Azure. You can imagine what we find here is DeepSeek, Mistral AI, again, all these that we had before. And basically they're available as a service. You can combine them nicely again, but of course you need an AI infrastructure for it, which is now, of course, also an interesting part of it, right? So leaving out the data for a moment, because we come to that also when we talk about infrastructure as a service very soon. But essentially you would have here this Amazon EC2 P5 instances, which are very prominent because this also stands for GPUs, very costly GPUs, as we will also reveal in the next slide. Because if you go there and now think about that you want to train a 100 billion model yourself using Amazon and maybe using this interesting AI infrastructure, you go and see and pay the price for it, right? As they here make basically also the market reading with 100 billion plus parameters at scale. Yes, you can do this. And you get actually cutting edge cards for it, H100 cards, right? So this is and H200 cards is really cutting edge. Blackwell is not really, penetrated in the market yet. This is the next generation. But with these instances, you see, you also have to pay the price on the hourly rate, right? And this model to train doesn't take 1 hour, right? Hence, we're talking about massive costs to do that your own, to train a complete 100 billion parameter model completely from scratch. Hence the idea of fine-tuning again, reusing some of the pre-trained models, and then maybe the cost is much lower, right? So hence, and it becomes much more feasible. You still need powerful GPUs to do that, right? So even fine-tuning an existing pre-trained model can accumulate to quite some costs in the cloud. And of course, this is pretty obvious to you, right? There's hence the incentive of this, to make that. And when you see now that more and more of these language models come available, I don't go much into the aspect of how it influences teaching. I mean, by now you all know that from assignments. But here's now an important factor. If you think about, for instance, the hospital here, and you have Google Translate, and let's say there are foreign doctors in the hospital that want to translate basically medical patients records, right? And you're a foreign doctor, and should I really do this? Because the data will then go to Google outside the country, somewhere where a Google data center is. So there are lots of these aspects which is not wanted. And I think you get the feeling when you want to share suddenly medical patient records of yourself with the cloud, there are leakages, whatever. So there's a kind of movement, I would say, to not only regulate this with GDPR and so on, but also talk about so-called European sovereign cloud services. And again, this would fill a complete lecture. What means European values, copyright issues, etc., not using medical data, sharing that in a non-anonymized fashion, etc., etc. So Tilde is here one example of this LLM model, which is, standing for the European Commission way of saying this is a large language model based on European values. And in a similar fashion, you have also Mistral here, I think coming from France, if I'm not mistaken, basically a European provider as well. And Mistral is also something which offers European hosted AI clouds, where at least we can be sure that within the framework of the European Union, the data is relatively safer than maybe putting it somewhere to China in clouds, basically with the new large language models come there, or basically to the US somewhere with Google. So there are different facets on it that even Google can offer you European data centers. Obviously, there are some tunings in it, but there's a large movement. It's, I think, also important that you know that. Coming a little bit to the end of the lecture, also what we do in Iceland here, and also putting one point at the, basically the problem of this LLMs. And this is something what we address in the so-called research project Trust LLM. So here we have the problem where low resource languages like Icelandic, Faroese, right, have basically very little text corpora to perform well in this training. You have seen, we talk about billions of parameters in large language models, and this pays a price. That means you need to have this parameters fueled with data to learn, right? This is lots of things to learn. And the trouble for these low resource languages is then that you don't have enough data and you don't train these as you would perhaps do in English, right? English text corpora is very often available a lot. And many countries have this problem, even, if you have Cypriot dialects or so. This is something which is known, and you can even top that with our hospital example, right? If you now have Icelandic as medical patient records and you want to keep that in Iceland and train large language model for Iceland, that's okay. That's already challenging. But if you then have rare disease patients, right, where medical records need to be translated for rare diseases, something which almost was never seen by the large language model in training, chances are it will also generate very interesting, stupid translations or something like this, because there's just not enough data to really learn the models well. So we're working in this research project against it together with the overall community here in the Natural Language Processing Lab. I teamed up with Hafstein Einarsson here, one of our professors, where I also would recommend you, if you have interest in the space of LLMs, he is really the expert. Bringing us to the next page, we have a couple of experts in our Icelandic HPC community in the natural language processing field in the NLP lab, doing PhDs and so on, and teaming up also what you have seen with SMEs like Methane. Here you saw basically the CEO, Linda, here in the press release that we basically got when we earned the big European, funding. And by now, that's something very big for us here in Iceland. Having so many funds is really from Europe, really a gain. Hence, we have talked also, of course, about the AI Factory antenna, if you remember. But before we move to this last point today, I just wanted to make you aware that what we talked about languages, and this is another example of a generative AI service, basically, and model, where you have different modalities in different Sentinel satellite data, but also, different aspects from radars and so on going into it. And the whole idea is that you do thinking in modality. So explaining TerraMind would require a complete university lecture at least, if not two. right? So, but the remote sensing lab is basically working on this, has published it together with ESA, with other big players in the field. You see here, the lab is led by Gabriel Cavallaro, a fellow professor in electrical engineering. So there are also lots of activities underway to have, this different modalities, optical, radar, land use, whatever you have as data, and generate something that is maybe missing in the downstream application. So if you reuse this and you would, let's say, some of the modality is perhaps not really existing, that it basically learns to create some modality, right? Hence, it will generate, modalities that maybe help then the classification of land cover. Is it a tree? Is it, water, etc. I leave it there. It's a big topic, and we see more and more things coming, leaving essentially the language space a little bit, right? So here we're talking more about satellite imagery, remote sensing, and so on. However, when we come back to maybe the final note today, when we think about, we already heard that also in the IHPC workshops, we got a very big grant, 1.4 billion krona is really very nice for us in Iceland. To have this Icelandic IFA for us. And you can see, that's why I bring it here in the slides, not to be proud again, but much more of saying, well, for this 5 million euro that we obtain, we basically will do also lots of large language models for the public sector in the different areas of healthcare, climate change, environment, renewable energy, manufacturing, engineering. So basically it's an orthogonal important priority. We will also have other AI, general purpose AI models, including foundation models to do transfer learning as we discussed. But here's really the key, also advancing a lot in the language modeling technologies for Icelandic, because if we don't do it in Iceland, no one will, right? So it's a low resource language. It needs lots of attention. So with the press release, you can learn more. We will also have a December EHPC workshop, again, focusing on IFRS and what we will do there. So there's more to come. Here's an interesting final note on the video I brought you today, which is essentially from the EVM cloud, talking to you again about GPT for generated, pre-trained transformers. It captures very nice the three, let's say, abbreviation parts, what we discussed today, generative, pre-trained, and transformer. So I would encourage you to look at that. And with this, we would break here and we'll continue with the next lecture after a small break. Talk to you soon.